Hi friends, in this video we are studying fluid mechanics subject, pressure and its measurement, objective questions and answers. And tank contains water up to the depth of 1 meter and above it an oil of specific gravity 0.8 for depth of 2 meter. The pressure intensity at the bottom of the tank. So in this question they are asking pressure intensity at the bottom of tank with some 4 options. So here we can see the diagram that a tank contains oil of depth of 2 meters and water of depth of 1 meter, and they had given the specific gravity of oil as 0.8. So let's write down the what are the given things. So here density of oil is 800 kilogram per meter cube because specific gravity is 0.8. So to find the density we are multiplying with density of water, that is 1000 kilogram per meter cube. So that gives us 800 kilogram per meter cube density of oil, and acceleration due to gravity is 9.81 meter per second square, that we know, and depth of oil is 2 meter, that is also given, and here rho 2 is density of water, that is 1000 kilogram per meter cube, and Z2 is depth of water. So here we can see in the diagram this height has a pressure of rho 1 G1 and H1 or Z1, whereas for water we have a pressure of rho 2 G2 and Z2. So they are asking about pressure intensity at the bottom of the tank. Therefore the total pressure at bottom is summation of both the pressures. So once we put the respective values we get the pressure of this value. So in kilopascal, if we divide it by 1000 we get it as 25.506 kilopascal. So option A is correct option. Differential manometer is used to measure very low pressure, pressure in pipes, atmospheric pressure, difference of pressure between 2 points. So here they are asking differential manometer is used. So here we can see the differential manometer. The main purpose of differential manometer is to measure the pressure difference between 2 points. There is point A and there is point B. We are measuring the pressure differences of these 2 points. So pressure at A plus, so let's take this as the datum line. So we have H1 and H2 amount of capillary fall and capillary rises. So here we can write PA plus rho 1 G1 H1 up to this point is equal to rho 2 G2 H2 for this mercury rise with the height of H2 plus PB plus rho 3 G3 and H3 because of this height. So PA minus PB, that is the difference of pressure. Therefore differential manometer is used to measure the difference of pressure between 2 points. A hydraulic press has a ram of 25 cm dia and a plunger of 5 cm dia. What is the weight lifted by the hydraulic press when the force applied to the plunger is 500 Newton? So here they are asking what is the weight lifted by the hydraulic press. So here we can see that there is plunger and there is a ram. So in hydraulics, the pressure exerted at the ram is equal to pressure exerted at the plunger. Therefore, we can write it as pressure at ram is equal to pressure at plunger. So, pressure is nothing but force upon area. So, at ram we have force upon area. Similarly, for plunger we have force upon area. So, we want here what is the weight lifted by the hydraulic press. So, that is at ram because weight lifting is carried at the ram. So, again weight is nothing but a force. So, force at ram is equal to, we can form this. So, once we put the values, it will be 2500 Newton per meter square. So, option B is correct option. In figure, the pressure of gas in a bulb is 55 centimeter of He. Vacuum and atmospheric pressure PATM is 78 centimeter of He. The height of column H is equal to. So here they are asking what is the height of column, because there is Hg and they have inserted a inverted tube and they are asking the height. So we can write that pressure at A, that is pressure of the gas bulb, is 55 centimeter of Hg. Therefore, pressure at A is 55 centimeter of Hg in vacuum, and atmospheric pressure, it is also given here, it is 78 centimeter of Hg. So here we want the pressure difference, that is nothing but a height difference. Therefore, 78 minus 55 is 23 centimeter. Therefore, 23 centimeter of Hg, option B is correct option. The specific gravity of oil in a pipe at 0.6 and mercury is 13.6. They are telling specific gravity of oil is 0.6 and mercury is 13.6. The equivalent gauge pressure is what when H1 is equal to 12 centimeter and H2 is equal to 17 centimeter. So we have a gauge and here they are given that we have H1 as 12 centimeter and H2 as 17 centimeter. So if we take this line as the datum line, because the pressure at 2 is equal to pressure at 3. Therefore, let me write this as right side and this as left side. So let's balance the pressures at the right side. So here the pressures are pressure at A, that is PA, and pressure due to this H1, rho G and H1, and this is the datum line. So let's come to the left side here. So here the pressure is due to H2. So this right side pressure is equal to left side pressure, that is rho 2 G2 H2 because of rise of H2. So we have the specific gravities. So we can convert that into density. So if we can multiply this with 1000, that will be the density of oil, and similarly we are multiplying 0.6 with 1000, so that is the density of second one. So instead of that we can put the values directly, because it is nothing but a same unit, so we can put it directly. So once we calculate the value of PA, it is 21.97 Newton per millimeter square. In order to increase sensitivity of U-tube manometer, one leg is usually inclined by angle theta. Sensitivity of inclined tube to sensitivity of U-tube is equal to, so let's see the diagram so you can come to know this. So in order to increase the sensitivity, the leg is usually inclined. So this portion is called as leg. Actually its shape is used to be vertical. To increase its sensitivity, it is going to be inclined. So the inclination gives it appropriate values as well as the very quick action when we raise the pressure. So we have H1 is equal to L sin theta, because we have angle theta here and this is the length. So we can form that H1 equal to L sin theta. So L upon H1 equal to 1 upon sin theta. Therefore, sensitivity of U2 is equal to 1 upon sin theta. Option B is correct option. Which one of the following pressure units represents the least pressure? So they have given the pressure units at millibar, mm of Hg, Newton per mm square and kg per centimeter square. So they are asking which one of these is a least pressure. So let's convert each unit into a atmospheric pressure. So we have to know these values. So we have to remember this. 1 millibar is equal to 1 upon 1013 atm. 1 mm of Hg is equal to 1 upon 760 atm. 1 Newton per mm square is equal to 1 upon 0.1013 atm. 1 kgf per centimeter square is equal to 1 upon 1.013 atm. So from above relation we can see here millibar denominator is a bigger value, so it gives a least value, because 1013, that is 1013, is bigger than 760 and respectively other two values. Therefore 1 millibar is the smallest value. Second one is 1 mm of Hg, that is 1 upon 760, As this is the bigger value, its product is least, and this gives the second least value. Therefore, 1 millibar is smaller than 1 mm of Hg, and similarly it is smaller than 1 kgf per centimeter square, and similarly it is smaller than 1 Newton per mm square. So we can conclude that 1 millibar is the least pressure. That is option A is correct option. When can a piezometer be not used for pressure measurement in pipes? Out of these four options, the pressure difference is low, the velocity is high, the fluid in pipe is a gas, the fluid in pipe is high viscous. So a piezometer has a tube and a pipe, but when the fluid in the pipe is a gas, we cannot use the piezometer, and we can use the piezometer when the pressure difference is low. Therefore option A is not suitable, and we can use a piezometer when the velocity is high, but we cannot use a piezometer when the fluid in the pipe is a gas other than liquid. Therefore option C is correct option. A U-tube manometer, as shown in figure, is attached to an air pipe, reads a height of 20 centimeter of mercury. What is the pressure in kilopascal in the air pipe? So we have a pipe with air, and it is connected to a U-tube manometer, and it is reading a height of 20 centimeter. So they are asking what is the pressure in kilopascal in the air pipe. So it is a very simple question. We can answer it as pressure at A is equal to rho g and h. Density of mercury is 13.6 into 10 raised to 3, and gravity and height is 20 centimeter, that is 20 into 10 raised to minus 2. So we get the values of 26.68 kilopascal. That is option A. Therefore option A is correct option. How is the difference of pressure head H measured by mercury oil differential manometer? We have four options here: A, B, C and D, where X is manometer reading, Sg and So are the specific gravities of mercury and oil respectively. So here the question is, how is the difference of pressure head H is measured by mercury oil differential manometer? So we have a relation H is equal to X into specific gravity of mercury upon specific gravity of oil minus 1. Here specific gravity of mercury is greater than specific gravity of oil. So option D is the correct option.
If you have any questions or comments, text in the comment box, and don't forget to subscribe, because subscription is free and also you get the notification of upcoming videos. And please like and share. Thank you.